Hello, welcome, and God bless you. Now, hear what you've all been waiting for. All those times I told you to take that calculator and make sure it was on degrees and not radians. Well, now you get to understand what it is about radians, what exactly they are, and how does this relate to a number of degrees. So, radians are another way of measuring the size of an angle as far as how much of it, how many degrees it is, but in another type of measurement. So let's think about, first of all, where this definition of a radian came from. Okay, radian sounds like radius. Okay, so if you make a circle and the circle has a center at the origin, and you had a certain um, radius to it, okay? A radian is however long that radius is, but if you take that measurement and you put it along the curve of the circle, that's where the term radian comes from. So we have this theta here equals 1 radian. If we measured this, we measured that, and they were the exact same length. Most of the time you won't revert all the way back to that, but I just need you to understand where these ideas come from. Okay, so the circumference of a circle, since we're thinking about a circle, is 2 pi r, as you probably remember. So if we know that the circumference of the circle is 2 pi r, wait a minute, r is this far. So that means there are 2 pi of these, so about 6.28 of these to go all the way around the circle. Interestingly enough, there's just 1 pi will get you halfway. Since 2 pi r gets you all the way around, 1 pi gets you halfway around, and we will talk about that a little bit more later. So 360 degrees all the way around equals 2 pi radians. Okay, notice that we've got the r, we've kind of skipped out on the r here, and so that's because however big the radius is, it's that length, and we will be dealing a lot with something called the unit circle, where we consider that to be 1, and all of our radian measure comes from that circle. So we will get to that. Okay. 180 degrees, as I said, halfway around, is just pi radians. Okay, pi times r, pi times the radius. So there would be pi of them, about 3.14 radians to get to here. And put it in context. 1 degree, okay, 1 degree is pi over 180 for that reason. Okay, so each 1 degree is pi over 180 radians. Okay, we're going to use that for a conversion factor. 1 radian, conversely, is 180 divided by pi. 180 degrees divided by pi gives you how much 1 radian equals. So we're going to do a little bit of conversions. Okay, if you're going to convert degrees to radians, you're going to multiply the number of degrees you have by pi over 180. Many times in your math classes, the radian measure will be given in terms of pi, not universally, but many times it will be. That would be the math that you would be hopefully able to do mentally, or at least partially mentally. And even on the college placement exams, they might want to see what you know as far as your math level, as far as whether you've had enough to go on to their next level on that. Radians to degrees, it's use the reciprocal. You're going to multiply by 180 degrees divided by pi. Okay, so let's just do a few of those for practice. degrees to radians, radians to degrees. So we'll start off, if we're going to take 45 degrees, look at it a little cleaner first. If you want to pause it here and write them down and try it on your own, that would be great. Cross-canceling is your friend. So when we're taking 45 degrees and we're going to multiply it by pi over 180, this and this can cancel out. Okay, 45 does go into 180. Think about 2 45s is 90, which would mean that 4 45s would be 180. So 1 over 4, pi over 4 is your simplified form. So 45 degrees is pi over 4 radians. Negative 270, you can have negative radians as well. So we multiply by pi over 180. 90 goes into 270 3 times. 90 goes into 180 twice, so you can once again cross cancel. And the right way to write that would be negative 3 pi over 2 or negative 3/2 pi also would be a very common way to write that. Now, when you have a decimal that you're changing over, just simply do that as a calculator problem. Okay, there's nothing that's really going to cancel out there. So you can use whatever calculator that you have as long as it's got pi on it. And you could just put that right in and then just multiply times pi and then divide by 180. And it'll give you your answer here, and we get 4.35 or 4.36 radians, 4.36 when we round it correctly. Okay, so pretty nice and simple on that. Also simple, also when you're doing converting it to degrees, a good way to remember that is the 180 degrees. We're trying to make degrees so that when that's in the numerator, you're turning it into degrees. When you have it in the denominator, you're taking it away from being degrees with the canceling out of units. So once again, cancel out as much as you can. The pi's here actually cancel out, which makes it nice and convenient. So we have 405 degrees. Pi's cancel out here. 6 goes into 180 30, so you get negative 150 degrees. And then 4.25, this is a decimal problem, so we could do a couple of different things here. We could do our calculator version of this, and 4.25 times 180 divided by pi. So we get about 243.5. Now, if we wanted to get a little fancy and you wanted to put it in degrees and minutes, remember there's 60 minutes in a degree, so half of a degree is 30 minutes. So you could do something like that if you wanted to, just as a little sideline and a reminding you that that does exist. Not necessarily used very commonly, but at least you've seen it. Okay, so when you are giving answers, it is important for you to say theta equals, or whatever your angle you're trying to find equals, and make sure that if you mean for it to be degrees, that you put the little degree mark. If you do not put the little degree mark, you are saying that it's in radians and it's something completely different. Just like I kept telling you on the calculator, make sure it's set to degrees. Make sure that you write degrees, or the person who's marking whatever your work you're doing has to assume you mean radians, which is a whole different thing. And I'll show you the example dealing with 30 degrees versus 30 radians. Okay, 30 degrees we know is this little angle right here, just takes us up this far. 30 radians, on the other hand, if we do the conversion here, 30 times 180 divided by pi gives us 1,718.87. And if we subtract 360 repeatedly, we have to do that 4 times. So it spins around 4 times and then finally lands at 278.87 degrees, which would be right about here. So you can see that 30 degrees is way different than 30 radians, so watch your symbols on that. Now there are certain numbers of degrees that are very common, and I'm going to suggest that you commit this to memory, or at least be able to figure out how many degrees go around. And we're going to do this by a figuring out method to start us with. So here we start with 0 degrees. This one we know is 90 degrees. Let's do the simple ones first. These are divided up, so this one's at 45 degrees, this one's at 30, and this one's at 60, but we're just going to ignore them for a minute. This is 180 degrees, 270 degrees, and we know that if we went all the way around, we would get to 360 degrees. I want to have all those things on here. So let's think for a minute about what we already know. We know that if we go all the way around the circle, we get to 2 pi. So 360 is the same thing as saying 2 pi. Or in radians, 0 degrees is 0 pi. That's kind of the easiest one. If we go halfway around, we already talked about that one. In terms of radians here, 180 degrees is 1 pi radian. Well, what about 90 then? 90 is halfway to 1 pi. So that would mean that in radians, 90 degrees is pi over 2. That's going to be important. So 0, pi over 2, pi. This is halfway between 1 pi and 2 pi, which would give you 1.5 pi. But you would never say 1.5 pi, you would say 3/2 pi. We prefer that. So 3/2 pi or 3 pi over 2. All those things work. So there's our first major ones: 0, pi over 2, pi, and 3 pi over 2. You need to start thinking in terms of radians as well as degrees. So let's go around and let's look at our 45-degree angles here. So 45 degrees. Okay, well, that's halfway between 0 and 1/2 pi. So halfway between 0 and 1/2 is 1/4. So pi over 4. Now, interestingly enough, you can start counting these, and it's going to be even a little bit easier to do the radian measure than the degree measure here. This one, 90 plus 45 is 135 degrees. 180 plus 45 will be 225. 270 plus would be 315. So there's our degrees. I have to think a little bit harder about that, but we're going to be counting here by 1/4. So 1/4, 2/4, which is 1/2. This one's 3/4. 3 pi over 4, or 3/4 pi. So 0, 1/4, 2/4, 3/4, 4/4, which is 1 pi. This one will be 5/4. This one would be 6/4. Well, we know 6/4 reduces to 3/2, so that makes sense. This one will be 7/4, 7 pi over 4. Okay, so right now we have our numbers that are going up by for the 45-degree angles, the ones that divided in half. Now the next ones, the third ones, are a little bit more interesting. So here we have 30 degrees, 0, 30, here we have 60 degrees, 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and finally 360. So bringing these things all around here, then we need to begin to think of it in terms of pi. Now here we start at 0, but we actually, when we think about here going all the way around, we have divided this up into 1, 2, 3, 4, 5, 6 equal pieces. So each one of these is 1/6 of pi. So here we're going to start counting by sixths. So this is pi over 6. This one is 2 pi over 6, which reduces to pi over 3. This one, 3 pi over 6, which is pi over 2. This one, 4 pi over 6, which is reduces to 2 pi over 3. And here we have 5 pi over 6, 6 pi over 6, which gives us pi, 7 pi over 6, 8 pi over 6, which reduces to 4 pi over 3, 9 pi over 6, which reduces to 3 halves, 10 pi over 6, which is 5 pi over 3, and then okay, so 10 pi over 6, 11 pi over 6, and finally 12 pi over 6, which is really just 2 pi. So these values, they can be figured out, but what you really should start doing is you should start thinking about these in terms of the degrees, but then also in terms of the radian measures in terms of pi. Okay, so all of these in terms of pi measurements are going to become very important. I would suggest that you make one of these circles, and we're going to be adding even more information to it for you to do other types of work. But this is a really, really important thing for you to know these main degree radian pieces on this circle, because these are the ones that give us our special triangles, our 30, 60, 90 triangles, and our 45, 45, 90 triangles. We've already talked about manually being able to figure out those values. So that's where we're headed with this. Bless you. Chew on this for a little bit, and I'll talk to you next time.